let's say you are given a function, and the function is x squared plus 5. Okay? What values can I plug in for x? Can I plug in negative numbers? Yes. Positive numbers? Yes. How about 0? Yes. And if we actually graph this, you will see that the domain of this function is negative infinity to infinity because there are no restrictions. And for all functions that are in this form, this is actually what we call a polynomial function. It has no restrictions. Now, the functions that have restrictions are the following. We have the rational function and the radical. For a rational function, such as 1 over x, whatever it is in the denominator cannot equal 0 because 1 divided by 0 becomes undefined. While in a radical function, whatever is inside the radical, we have to make that greater than or equal to 0 because we can never take a square root of a negative number. So, to find the domain of a function if you're given an equation, we need to exclude values of x that make the denominator 0. Or if you have a square root, we have to restrict the domain so that we have no negative values. So this is how we do it. For part A, we have a denominator. So we set that to equal 0 to solve for the zeros. So solving for x, we find that when x is equal to 1, 2x minus 1 will equal 0. That means the domain will not include 1. So that goes from negative infinity to 1 to infinity, not including 1. For part B, this can never equal 0. There are no values of x that will make this 0 because it is being added by a positive number. So for B, the domain is negative infinity to infinity. Same thing for D. Part C is a radical function. Notice the square root. So what we have to do is set that expression t plus 4 greater than or equal to 0 to know the restrictions of the domain. So the domain starts from 0 to infinity.